In this demo, I'm going to show you how Tom, a developer, might interact with the Coverity platform. Like many users, they've configured Coverity to analyze their project in the background as part of their continuous integration, continuous delivery process. It automatically assembles a comprehensive base of code intelligence, which it analyzes to identify quality and security issues that developers need to address. We start the demo as Tom arrives at work after checking in some changes the night before. One of the first things Tom does is check his email. Tom notices that Jenkins failed the build last night and he has a Coverity notification about some problems in his code. While most users have an email-based workflow like this, it's not the only option. You can base your workflow on other important tools like your IDE, ALM system, or bug tracking system if you prefer. Tom likes to keep his code clean, so he addresses the Coverity issues first. In fact, the Coverity failures actually triggered the failed build in Jenkins. Opening the new issue, we go straight into the Coverity Connect web interface. Notice how this issue has already been assigned to Tom, since he is the developer that committed the code change. This is one way that the Coverity platform streamlines and automates the developer workflow, minimizing housekeeping work. Focusing on the source code, we can see that last night's changes introduced a cross-site scripting vulnerability. In particular, Tom added a variable theme in the JSP to allow for UI customization. The value is read directly from a request parameter on line 19 and output directly into the response on line 30. In case you're not familiar with the cross-site scripting vulnerability, you can read the info in the upper right, which includes a link to the full CWE description. In short, an attacker could craft a parameter value that executes JavaScript to get unauthorized access to the user's browser and private information when they access this page. The remediation guidance in yellow tells Tom how to fix the problem. Namely, he needs to sanitize theme before he outputs it. We actually detect the context hierarchy into which the value is output, and the remediation advice tells you how to properly sanitize for that specific context. In this case, Tom has a couple of steps, including using the escape.uri method from the open source Coverity security library to sanitize the value to be safe when output as a URI inside an HTML attribute. Tom would normally fix the issue at this point, but he wants to look at a resource leak that he didn't have time to fix last night. He's going to update the status so he doesn't waste time reviewing it later. To see the resource leak, he can just pull up his outstanding issues right here. Tom appreciates the convenience of having all his action items in this one place. This resource leak is pretty straightforward. We have request input stream, which is allocated a resource in get file from zip. We can see that it's not null since we take the false branch on line 399, and it's not released in the case where getString from input stream returns null. That getFile from zip function is actually a custom implementation, so how do we know that it allocates a resource? Simple, we analyze all the functions to determine what they do. In this case, we can see that getFile from zip returns a new input stream allocated on line 550. Moreover, we follow that resource as it is passed to getString from input stream on line 401 to verify that it isn't closed or reassigned there. This one also needs to be fixed, so Tom updates the status and moves on to fixing the issues. Note how all issues are managed in the same way. In fact, they funnel all their quality, security, architectural, and testing issues into the Coverity platform, where they enjoy one consistent developer workflow that leverages automated interactions with their build and bug tracking systems. They're in the process of discussing a clean before check-in workflow, which would analyze the code before it is checked in, so that developers fix problems even sooner. They're still trying to decide which IDE the team wants to use as part of that transition. They might decide to perform the analysis via a pre-commit hook in Git. Either way, Coverity has them covered. The Coverity platform enables developers to focus on writing high-quality, secure code without having to remember to run or check various analysis, bug tracking, or other tools. The analysis tools run automatically as part of the workflow, consolidating those findings so that developers can easily find and prioritize everything in one place. The benefits of an automated, efficient developer workflow extend beyond developers to management and teams like QA and security that work with developer output. They enjoy greater visibility and predictability, leading to a more agile and efficient process, and ultimately producing a higher quality, more feature-rich offering that end users can't get enough of. To learn more about Coverity and how we can help you, please visit our website or email info@coverity.com.